section is kind of quick on scalar product. We're not going to prove this, but if we do, a scalar product is when there's several ways to multiply. One we're going to find is the cross product. The other is the dot product. This is often called the dot product. And it is the magnitude of A times the magnitude of B times the angle in between. Does that sound familiar at all? Yeah, Kurt? Yeah, it's kind of like the law of cosine. Okay, so we're going to get there. So what we're doing is if you take two vectors like 2, 5, dot, -3, 2, okay, and you multiply those out, what does it give you? What does it represent? We're going to answer all those questions, okay? First thing, I'm going to tell you what it's used for, and then we're going to prove what the product is. It's used for finding parallel vectors and perpendiculars. This is rare. This is often. You're going to find perpendicular ones a lot. But this is probably the best one, angles in between. Yes? What is cosine? What is theta? Yep. So we'll get to that as well. Let me just, since you asked, we're going to do it. So here's a vector A, and here's a vector B. All right. What we're going to do is remind you that vectors have what? Magnitude and direction. So I can put this anywhere I want. Does it still have the same magnitude and direction? Yeah. Well, I'm going to put these right here. So the tails are next to each other, and then I get a theta in between, and then this is what's going to enable me to find the angle between these two vectors. By the way, this is huge. I'll tell you my little personal story. I think I told you this in honors pre-calc too, where my father-in-law called me. Yeah. And he didn't really like me that much. And I'm not saying that to be critical. I'm just saying a fact. And so one day he called me out of the blue, and he says, I'm designing this log home. He had a log home company, and he needed to find the angle between these two roof lines, and they were in 3D. It was one gutter that was going this way, and then another one coming this way, and then there was another one coming in this direction, and he wanted to know what this angle was. And I said, sure, I can help you do that. So I designed two vectors. I found points in space, 3D here, made two vectors, and then I used the formula that I'm just about to teach you. And he said, thank you. And he hung up. I said, okay. So then about a month later, I get this call. He said, Tim, we built this roof, and we used the specs that you gave, and your angle was off by less than a 1/16 of an inch. Thank you, he said. Not a lot of emotion there, but it was still good. So math can save not only a marriage, sometimes whole relationships. Pretty cool. Anyway, we're going to develop this formula here, and A star B is going to be equal to the product of the x's, y's, and z's, which is pretty cool. And I thought I had, yes, I do. We're going to, can you find this pink slide? And I think we did this in honors pre-calc, but we're going to do it again real quick. This is magnitude A, magnitude B, and then we'll look at the cosine of the angle in between them, reminding you that the cosine of 90 is how much? 0 or 1? Good. I like you're kind of drawing a circle in your mind. Yeah, the cosine of 90 is 0, right? What's the cosine of 0? 1. So if two parts are at an angle of 90 to each other, what's the dot product going to be if they're 90? Cosine of 90 is? Cosine of 90 is 0, right? So this is going to be 0. And if they're parallel to each other, the cosine of 0 is 1. Okay, so we'll keep that in mind. We'll remember that. So I is a vector in the x direction, j is a vector in the y direction, and k is a vector in the z direction, jk, like that. So I dot I are in the same direction. What's the cosine of 0? 1, right? What's j dot j going to be? 1. What's k dot k going to be? 1, because the cosine of 0 is 1. What's I dot j going to be? That's going to be 0. This angle between is going to be 0. J dot k, something like this, that'll be 0. And I dot k will be 0. So far, so good. Now what we're going to do is we're going to take, and now this was supposed to be separated here in between. I don't know why these are together. But we're going to take this position vector and this position vector and multiply them out. But the unfortunate thing is we have to FOIL these out. So this one is going to be x1 times x2 times I dot I. And then I'm going to take this one times these two, which will be x1 times y2 times I dot j. You see what I'm getting at? Probably. And then these two are going to be x1 z2 I dot k. That's that row. Now we're going to do the next one. Plus y1 x2 j dot I plus y1 y2 j dot j, and then it's going to be y1 z2 j dot k. There's that row. Now we have one more to go. Plus z1 x2 k dot I plus z1 y2, right? K dot j. And then the last one, z1 z2 k dot k. So which ones are going to be 0? Will j dot I be 0? Or I dot j? Cosine of 90 is 0. Cosine of 90 is 0. Cosine of 90, cosine of 90, cosine of 90, cosine of 90. The cosine of 0, I dot I, is just going to be what? Cosine 1 and j dot j and k dot k. So what you're left with is the dot product, which is x1 x2 plus y1 y2 plus z1 z2. Or for an example, if you had 1, 2, 3 dot negative 1, 2, 3, you're going to get 1 times negative 1 plus 2 times 2 plus 3 times 3, which is just going to be 4 and 9 is 13 minus 1 is 12. 12, yeah. Yep. For vectors, there's really no multiplication. There's either the dot product or the cross product. I'll tell you right now, the dot product product is what tells you a number. And if that number is anything other than 0, it's going to help us find an angle. If it's 0, we know that it's what? Cosine of 0 is 90, or cosine of 90 is 0, so yeah, these will be perpendicular. If this is 0, that's telling. But if it's anything else, we're going to use it to find the angle. Yes, that's what is going to be the goal, yeah. So when we find the angle, remember we had that formula, A dot B was equal to magnitude of A, magnitude of B, cosine of the angle. Well, if we solved algebraically for the angle, you're just going to get the dot product over this. This is what I was telling you, the power of this is that you can take three-dimensional vectors, find the angle between them just by doing this crazy math. So let's take this example. Vector A has a column vector of 3, -1, 5. That's A. I like the column vector form. B has a -2, 4, -1. So what's the magnitude of this A? Well, it's the square root of 9 plus 1 plus 25. In your head, do you get square root of 35? B is the square root of 4 plus 16 plus 1, which is the square root of 21. The dot product, use this little technique that I showed you by taking the 3, -1, 5 and the -2, 4, -1 and just multiply across and add them together. X1, X2. X1, X2, Y1, Y2, Z1, Z2. So that's going to give you -6 minus 4 minus 5 is -15. So to find the cosine, it's the dot product over magnitude of A, magnitude of B. So the cosine of theta is -15 over square root of 35, square root of 21. Ooh, that negative looks bad, doesn't it? Go in your calculators, be in the degree mode, because we want a degree, not a radian answer for this one. And tell me what the inverse cosine of -15 over square root of 35, square root of 21. Can you tell me what that is? It's going to be between 90 and 180. 124.5. Can't you just feel the accolades from your future father-in-law coming in now that you figured that out? So good. That is so crazy that you can do that. Is that what you got, 123? That's all right. No, that's not. No, that's fine. I appreciate you giving me that answer. 123.6? Like that answer too. Very good. So that's how you find the angle. You find the dot product, divide by the magnitude of each, and you've got it. Very powerful. A couple things. When the dot product is 0, they're perpendicular. That's a good thing to know. If the dot product is equal to the product of the magnitudes, they're going to be parallel. And we didn't talk about that very much, but if you take cosine theta equals magnitude or of A dot B over magnitude of A, magnitude of B. If they're parallel, what's the angle between them if they're parallel? 0. What's the cosine of 0? 1. So if the dot product is equal to cross multiply magnitude of A, magnitude of B, do you see how that plus or minus could be parallel? They could be this way or this way, parallel. Not a big deal, but I just thought I'd mention that. Happens very rarely. A dot 0 is a 0 vector. We're good with that. Okay, and last thing, finding values for m which make the vectors perpendicular. If we took 5m coefficient, negative m coefficient, negative 3, and dot product it with what's the coefficients of this vector? IJK coefficients. M what? 7 and 2. If you took the dot products, if they're perpendicular, that should be equal to 0. So all you do is go 5m squared minus 7m minus 6 equals 0, and you can factor and find the m that makes that true. Just a little side problem. And then would you take this slide and put a big X through it? We're not going to do that because we're going to use cross product. You won't need to do that. So for homework, you can use those formulas. The primary formula is cosine theta is A dot B over magnitude of A, magnitude of B. And don't forget, A dot B is x1, x2, y1, y2, z1, z2. Those should go great. Finding the angles will go well. These will make you think. And these all look great. You can check those answers.